The humble stapler, a staple in every office, holds a secret. Its design follows a mathematical pattern that has been hiding in plain sight for centuries. This pattern, known as the Fibonacci sequence, is found in the arrangement of staples within the stapler's magazine. In fact, the number of staples in each row follows the sequence 1, 1, 2, 3, 5, 8, and so on. But why is this important? Well, the Fibonacci sequence is more than just a mathematical curiosity. It has real-world applications in design and engineering. For instance, the spiral shape of a nautilus shell follows the Fibonacci sequence, allowing it to grow and expand with maximum efficiency. Similarly, the arrangement of leaves on a stem follows the Fibonacci sequence, ensuring that the plant can photosynthesize and grow to its full potential. And it's not just plants and animals. The Fibonacci sequence can be found in the design of everything from bridges to buildings. So, what's the connection between the stapler and the Fibonacci sequence? It turns out that the stapler's design follows the same mathematical pattern as the sequence. The staples in the magazine are arranged in a way that minimizes waste and maximizes packing efficiency, making it easier to produce and use the stapler. But that's not the strangest part. The Fibonacci sequence is also found in the way that the staples are bent and formed during the manufacturing process. In fact, the angle at which the staples are bent follows the same mathematical pattern as the Fibonacci sequence, allowing for a more efficient use of materials. And it's not just the staples themselves. The shape of the stapler's nose and the way that it grips the paper also follow the Fibonacci sequence. This means that the stapler's design is not just a matter of aesthetics, but is actually a carefully crafted solution to a complex mathematical problem. But why should we care about the Fibonacci sequence and its relationship to the stapler? Well, understanding this pattern can help us design more efficient and effective products. For instance, by applying the Fibonacci sequence to product design, companies can reduce waste and save money on materials and manufacturing costs. Additionally, understanding the Fibonacci sequence can also help us appreciate the beauty and complexity of the natural world. So, the next time you reach for a stapler, remember that it's not just a simple office tool, it's a complex mathematical system in action. In fact, the stapler is just one example of a larger class of objects that follow the Fibonacci sequence, known as Phi-Objects. Phi-Objects are characterized by their unique mathematical properties, which allow them to grow and expand in a way that is both efficient and beautiful. But Phi-Objects are not just limited to the natural world. They can also be found in human-made objects like art and architecture. For instance, the famous golden ratio, known as the golden rectangle, is a Phi-Object that has been used in art and design for centuries.
The golden rectangle is a rectangle with a length-to-width ratio of 1.618 to 1, which is the same as the ratio of the Fibonacci sequence.
This ratio is said to be aesthetically pleasing and is often used in design to create a sense of balance and harmony, which is the limited to art, and same as the design they can ratio of the also be found in Fibonacci science and sequence engineering. For instance, the spiral shape of a galaxy is a Phi-object, and understanding its mathematical properties has helped us better understand the behavior of galaxies. Similarly, the arrangement of atoms in a crystal is a Phi-object, and understanding its mathematical properties has helped us develop new materials and technologies. So, the next time you encounter a Phi-object, remember that it's not just a pretty face, it's a complex mathematical system in action. In fact, Phi-objects are all around us, waiting to be discovered and understood. And by applying the Fibonacci sequence to our lives, we can unlock new insights and innovations that will change the world. So, what's the next step in our journey of discovery? By understanding the Fibonacci sequence and its relationship to Phi-objects, we can unlock new possibilities for design, engineering, and innovation. Next big weekend breakthrough will unlock comma from a new stapler. So, let's continue our journey of discovery and see where the Fibonacci sequence takes us.
By applying the Fibonacci sequence to our lives, we can unlock new insights and innovations that will change the world.
And it all starts with a simple stapler. Subscribe to our channel for more fascinating stories about math and science. And don't forget to like and comment below. We love hearing from you. Thanks for watching, and we'll see you in the next video.